Okay, so today we're doing lesson 17C and homework 17C, and we're still solving systems algebraically, but you're going to get your systems from a word problem. So what I've done is I've printed out a sample of your assignment, and so here I have 5 word problems. They are almost identical to yours. It's the same scenario, the same setup, everything. The only thing that's going to be different are the numbers that you're using. Okay, so what I'm going to do is just walk you through each problem that I have here on my paper, and then use my examples to do your word problems in Math Excel. Okay, and like I said, the setup is the same, the scenario is the same. The only thing that's going to change is the numbers in each problem. All right, now I've zoomed in a little bit, so hopefully it's a little bit easier to see. Hopefully it looks a little bit better. And let's get started. So some things that you're going to need to do for your word problems. You need to define the variables. You need to create a system and then solve the system. Okay? So number 1, a student has some $1 and $5 bills in his wallet. He has a total of 15 bills that are worth $39. How many of each type of bill does he have? So we're talking about bills and dollars, okay? So we have 2 different types of bills. We have $1 bills and $5 bills. So I'm going to use those to create my variables. I like to use variables that make sense to me. And I think in this case, I don't think any of them, except that one of the last ones, it tells you what variables to use maybe, but the rest of them, you can kind of use whichever ones make sense to you, okay? So we're talking about $1 bills and $5 bills. So I'm going to say that O represents $1 bills, and I'm going to say F represents the $5 bills, okay? So that's the first thing. Now, we have a total of 15 bills. So that means if we add up the number of $1 bills plus the number of $5 bills, we should get 15. Okay? And we know that the bills are worth $39. So our next equation is going to have to do with money. So we know that $1 bill is just worth 1, and a $5 bill is worth 5, and then that total is 39. Okay, now I guess I should have probably done a different variable there. Let me change this to, let me use D for dollar bill, and then it'll be a little bit easier to see. So here's our system, and we're just going to solve it. Okay, so we're looking for our matching variables. We do have matching variables here. Both of those coefficients are 1. All right, so we're going to look at that box. Those have the same sign, so we're going to subtract. Oh, sorry about that. 5 o'clock light turn off. Okay, so we're going to subtract. Those cancel out. F minus 5F is negative 4F. 15 minus 39 is negative 24. And we divide by negative 4, and we get F equals 6. So F is $5 bills, so we can say there are 6 $5 bills. Now we need to know the number of $1 bills. So we're going to take this 6, plug it back into our original equation, and solve. So we'll subtract 6, and we get D equals 9. So there are 9 $1 bills. Okay, next, the average apartment rent in country A is $1,320 per month. Jacob has an apartment in city B and one in city C. The total monthly rent for the 2 apartments is $4,724. The rent in city B is $1,112 less than the rent in city C. Find the rent for each apartment. Okay, so in this one, that first sentence really throws us off. We don't really need that, so I'm going to ignore it. And we're talking about Jacob's apartments in city B and in city C. And the total rent for the 2 apartments is $4,724, and then city B is $1,112 less than city C. So we're talking about the apartments and then money, okay? So let's define our variables. I'm going to say the apartment in city B is B, and the apartment in city C is going to be C, okay? That makes sense to me. And if we have, or the rent for those apartments. So if I add the rent for city B and city C, the total is $4,724. Okay, so there's that equation. Now, the other one, it says B is, so that's B equals $1,112 less than city C. So we're going to do C minus 1,112. Okay, and we can solve this using substitution. Okay, because we have a B equals. So we're going to take what B equals, we're going to plug it in for B and solve. So that's really going to be C minus 1,112 plus C equals 4,724. Combine like terms gives me 2C minus 1,112 equals 4,724. I add that to both sides, and I'm running out of room. And so I get 2C equals, make sure I write that down correctly for you, 5,836. I divide both sides by 2, and I get C equals $2,918. Okay, now I want to solve for B, so I'm going to plug that number in for C. And so 2,918 minus 1,012. And that gives me 1,806. So the rent for apartment B is $1,806. Okay, so that one you had to use substitution. Okay, next, during the holiday season, Brianna sold scarves at a kiosk in a shopping mall. Embroidered floral scarves cost $24 each, and sheer chevron scarves cost $19. One day she sold 46 scarves. Total receipts for the day were $969. How many of each kind of scarf did she sell? So here we're talking about embroidered floral scarves and sheer chevron scarves. So, and I don't know why I didn't think of this in the other two problems, but it tells you that right here what we're talking about. So for embroidered floral scarves, I'm going to use E. For sheer chevron, I'm going to use S. Okay, so we're talking about the number of scarves and then the cost, or how much she made from the scarves. So first, we know that she sold 46 scarves. So for our system, we have E plus S equals 46. If you add together both sets of scarves, you should equal 46. And then the total receipts for the day were $969. So every embroidered scarf was 24. So that's 24E plus sheer chevron scarves were 19. So plus 19S equals 969. So here we have a system set up for elimination, but our variables don't have matching coefficients, so we're going to have to make them match. Since both of the coefficients on the top one are 1, then we can multiply that top equation by something. I'm going to choose the smaller one. I'm going to use the S's. I'm going to multiply the top one by 19. So I have 19E plus 19S equals 874. And then I'll bring over the bottom one. And those have the same sign, so we're subtracting. And I'm running out of room a little bit. So 19 minus 24 is negative 5. So that's negative 5E equals negative 95. You divide both sides by negative 5, and you get 19. So we sold 19 embroidered scarves. Okay, now we know E plus S equals 46. So that's 19 plus S equals 46. You subtract 19. and we get S equals 27. So we sold 27 chevron scarves. Okay, number 4, the point at which a company's cost equals its revenue is the break-even point. C represents the cost in dollars of X units of a product, and R represents the revenue in dollars from the sale of X units. Find the number of units that must be produced and sold in order to break even. That is, find the value of X for when C equals R. So this is a break-even problem. It's probably the most common application of systems of equations. Okay, and so it gives you what C equals and it gives you what R equals, and it tells us that we're going to set C equal to R. So if C equals R, then this quantity equals this quantity. So that's what we're going to set up. 13x plus 450 equals 15.5x. Now, that's just a multi-step equation that we're going to solve. So you can subtract 13x from both sides, and you get 450 equals 2.5x. We divide both sides by 2.5. And you get 180 equals x. So they have to produce 180 units to break even. That means that they're not losing money and they're not making money. They're even. And that's really important for any business. If you want to run your own business someday or work in a business, this is going to be really important because you need to know when you're going to stop losing money and start making money. So that's where that break even comes in. All right, number 5 is our last one. The coffee counter charges $7 per pound for Kenyan French roast coffee and $6 per pound for Sumatran coffee. How much of each type should be used to make a 20-pound blend that sells for $6.50 per pound? Okay, so we're talking about pounds of Kenyan roast and Sumatran coffee. So let's make our variables. So Kenyan roast, let's call that K. Sumatran, let's call that S. And so first we want to know how many pounds. So a blend to make 20 pounds. So we're going to use both the Kenyan and the Sumatran to make 20 pounds. Okay. Now, when we're talking about money, it's $7 per pound for the Kenyan. So that's 7 per K, and it's 6 for Sumatran, so that's 6S, and then that equals. And so we're wanting to know a 20-pound blend that sells for $6.50 per pound. So that's $650 per pound. So we're doing 20. So that's going to give us another multiplication problem. So we're going to have to do 20 times 650 and see what that gives us. And after you do that math, that is 130. So that 130 is going to go down here because we have to account for the $6.50 per pound, and it's 20 pounds total. Okay, so we have our system. It's ready for elimination. We just have to get the variables with matching coefficients. So you can do set K or S here. It really doesn't matter. You just choose. I want to use S just because it's a smaller number, but really they're only one different, so it's really not going to make that much of a difference here. So I'm going to look at the S's. So that means I need to multiply the top one by 6. So that's 6K plus 6X equals 120. Then 7K plus 6X equals 130. These have matching coefficients, same sign, so I subtract. 6K minus 7K is negative 1K. Our 6S's cancel. 120 minus 130 is negative 10. I have to divide both sides by that negative 1 to get a positive K equals 10. So 10 pounds of Kenyan roast. And now we're going to take that 10, plug it in for K, and solve for S. So that's 10 plus S equals 20. Now, that should be a giveaway, but if you need to, you can subtract 10 from both sides, but you do get S equals 10. So 10 pounds of each roast of coffee. Okay, so like I said before, your 5 problems in Math Excel should be extremely, extremely similar to mine. The only thing that's going to be different are the numbers that you're using. So this is going to require you to look back at my examples, use your numbers in my setup, okay? So I'm showing you how to set everything up. You are just going to have different numbers in there, okay? So I will also upload this example sheet for you in Google Classroom, because I know that it might be difficult to pause and look back. If you would rather have it just as the paper, it will be there for you, okay? But use this to help you in Math Excel. If you need my help, let me know.